Lagrange multipliers. If we have a function on two variables, f of x, y, and we need to optimize it, that is, find its maximum, subject to constraint g of x, y equals to 0, then Lagrange multipliers will tell us to do the following. We need to satisfy constraint, and if we have function attain its max or mean at a point, then at this point gradient at function and gradient at constraint, they're going to be parallel, so gradient of f equals to lambda times gradient of g. And for function of two variables, second formula will tell us that is partial derivative with respect to x equals to partial derivative with respect of x of function g times lambda, and partial derivative with respect to y of function y equals to lambda times partial derivative with respect to y of g. So we're going to have three equations. And we're going to have three unknown variables, x, y, and lambda to find, and hopefully we'll be able to do that. We want to find maximum values of function f subject to constraint or constraints. We have function f of x, y equals 2x plus y, and we have constraint x squared plus y squared equals to 1. We want to do Lagrange multipliers, so we'll find gradient of f, partial derivative with respect to x is 2, partial derivative with respect to y is 1. Our function g of x, y, we move everything on one side, so we're going to get x squared plus y squared minus 1 equals to 0. So partial derivative of g with respect to x is 2x, partial derivative of g with respect to y is 2y. So if we want to use Lagrange multipliers, then we're going to get x squared plus y squared minus 1 equals to 0. That's our constraint which we need to satisfy. Second one will say 2 equals lambda times 2x, and 1 equals to lambda times 2y. So the second and third equation will tell us that the gradient of f and gradient of g are parallel. So from the first one, from the second one, we're going to get 1 equals to lambda times x. So from here we're going to get lambda equals to 1 over x. And we're going to substitute into a third one. So we're going to get substitute into the last one. So we get 1 equals 1 times x times 2y. So from here we're going to get x equals to 2y. And we're going to take x equals 2y and now substitute into a constraint into the first equation. So we're going to get 2y squared plus y squared minus 1 equals to 0. So 4y squared plus y squared minus 1 equals to 0. So 5y squared minus 1 equals to 0. So y squared equals to 1 over 5. So we get y equals to plus or minus square root of 1 over 5. And x equals 2y, so x is going to be equal to 2 times plus or minus 1 over over square root of 5. So we get 2 points to consider. X equals to negative 2 divided by root 5 and negative 1 over root of 5. And second point is x equals to 2 over root of 5 and y equals 1 over root of 5. At the second point, f of x, y is going to be equal to 2 times 2 over root of 5 plus 1 over root of 5. We simplify that expression, we're going to get 5 over root of 5, 5 over root of 5 over root of 5. Second one, for first one, we will substitute in negative 2 over root of 5 for x, negative 1 over root of 5 into expression for f. So we're going to get negative square root of 5. So our answer is going to be square root of 5. Maximal value function is going to be square root of 5. That will be maximal value. And the minimal value function is going to be negative square root of 5. That will be a minimal value function. And maximal will be attained at 0.2 square root of 5, 1 square root of 5. And minimal will be attained at point negative 2 over square root of 5 and negative 1 over square root of 5. Next problem, we want to find max or mean of a function f of x, y which equals xy, subject to constraint 4x squared plus 9y squared equals to 36. So we want to use Lagrange multipliers, so we know what our function is, f of x. We know what our constraint is, 4x squared plus 9y squared minus 36. So we can find partial derivative with respect to x, partial derivative with respect to y, partial derivative with respect to x is y, partial derivative with respect to y is x. We'll do the same for constraint, partial derivative with respect to x is 8x, partial derivative with respect to y is 18y. So we're going to get Lagrange multipliers. We're going to write down 3 equations. First one is our constraint. Constraint equals 0. 4x squared plus 9y squared minus 36 equals 0. Second and third will tell us that the gradient of f is parallel to gradient of g. So f derivative with respect to x and derivative with respect to g of constraint equals basically the same. The only difference is they are multiplied by lambda. So I multiply the first one by second one by y. I'll multiply the second one by x. If I do that, I'm going to get y squared equals to lambda times 8xy, and x squared equals to lambda times 18xy. I'm going to multiply this last one by 4, and I'm going to multiply by second one by 9. So I'm going to get lambda 72xy equals to 9y squared. Second one will be 4x squared equals to lambda 72xy. Going to subtract them. So we're going to get 9y squared minus 4x squared equals to 0. So 9y squared equals to 4x squared. And now I know 9y squared equals to 4x squared. I'm going to substitute into the constraint. So instead of 9y squared, I'm going to write down 4x squared. 4x squared plus 4x squared minus 36 equals to 0. 8x squared equals to 36. So x squared equals to 9 over 2. So x equals to plus or minus 3 divided by root of 2, taking square root of both sides, square root of 2. 9y squared equals to 4x squared, and x squared equals to 9 over 2. So y squared equals to 2. So y equals to plus or minus root of 2. So we have a choice of 4 points here. X equals to negative 3 over root of 2, y equals to negative root of 2, y equals to negative 3 over root of 2, y equals to positive root of 2, x equals to 3 over root of 2, y equals to positive root of 2, and x equals to 3 over root of 2, y equals to negative root of 2. So we take these 4 points and we substitute into our function which we want to optimize, and we want to see what's going to be happening to this point, and we figure out that f at the first point, negative 3 over root of 2 and negative root of 2 is going to be 3. F at negative 3 over root of 2 and root of 2 will be negative 3. F of 3 over root of 2 and negative root of 2 is going to be negative 3. And f of 3 over root of 2 and root of 2 is going to be 3. So 3 is going to be our max, and negative 3 will be our mean. So max of function is 3, mean of f of xy is